Lesson 10.6, Trigonometric Ratios. The objective is to solve a right triangle using trigonometric ratios. This is just the first part of it today. We'll look more of that solving a right triangle tomorrow. Today we're just kind of going to work on what each trig function does and what it stands for, and how you write the ratio, and also we're going to use the calculator to let you see how easy that part is. Tomorrow we'll do more of the solving. So we're going to start off with learning a new term, and it's kind of cool that we're Indians here at Milan, because that might be considered an Indian term. It's called SOHCAHTOA. That will become near and dear to your heart. You will remember SOHCAHTOA because that helps you remember what you're doing with these trig ratios. So first of all, we are only going to deal with the three main trig functions: sine, cosine, and tangent. There are three others that you will get to when you're in more of a pre-calculus, probably maybe even geometry stage. But what they're defined as is this. Sine, it's spelled S-I-N-E. Okay, we abbreviated, and you would see it on your calculator, is S-I-N, but you do not say sin. Okay, you want to sound educated, and you know that stands for sine. Okay, so please don't ever say sin. That just means that you don't even know what the name of it is. So sine is defined as opposite over hypotenuse. I realize you don't know exactly what we're talking about right now, but we'll get there. Cosine, it's abbreviated with COS, and just because on your calculator button it says COS, don't call it cos. Okay? You're going to know that that stands for cosine, and that's adjacent over hypotenuse. And then finally, tangent, it's abbreviated TAN, but you don't say tan. It's tangent, and it's opposite over adjacent. So SOHCAHTOA is used to help you remember sine, opposite over hypotenuse; cosine, adjacent over hypotenuse; TOA, tangent, opposite over adjacent. So now we got to figure out what that opposite and adjacent business is all about. Well, this has everything to do with right triangles to begin with. All right, so we have a right triangle sitting here, and a right triangle is labeled ABC. Now, capital A, capital B, and capital C refer to the angle vertices. Okay, so you would say that is triangle ABC. All right, and for all practical purposes, when you start talking about trigonometry, they're going to use all A's and B's and C's. You should even maybe think, that's probably why Pythagorean theorem uses A squared plus B squared equals C squared. It's usually a standard thing to begin with A, B, and C. Now, will it always be A's and B's and C's? Nope, sure won't. That's why you've got to remember SOHCAHTOA. Okay, so notice a couple of things. C is always the right angle. Okay? C is always the right angle. That's really important. Notice that the side opposite the angle is the lowercase letter. So opposite angle A is little a. Opposite angle B is little b. Opposite right angle C is little c. Okay, that's something that needs to be pointed out to you. The opposite side is the lowercase letter of the opposite angle. The lowercase letter stands for the length of that side. Okay, also, the hypotenuse. For all practical purposes, what we're talking about today, hypotenuse is always going to be C. The hypotenuse is always the hypotenuse. And you're thinking, well, of course it is. Well, it'll be amazing how much you guys will forget and try to use the hypotenuse for an opposite and adjacent, but it's never that. All right, let's try to figure out what we mean by opposite and adjacent. Let's talk about angle A. Angle A is right down here. There are two legs in this triangle. One of the legs is opposite angle A, and one of the legs is adjacent to angle A. The one opposite angle A is little a. The opposite is always that letter that matches. It's across from it. Adjacent means next to. Well, it just so happens that adjacent is the leg that's actually part of the angle itself. That's how you tell the difference. Opposite is across the triangle from it. Adjacent is actually one of the sides of the angle. And remember, hypotenuse is never one of those. So don't sit there be thinking, well, how do you know it's not C? It's adjacent to A too. Well, yeah, it is, but it's not even in the running or consideration when you're talking about opposite and adjacent. Opposite and adjacent refer to the legs. The hypotenuse is the hypotenuse. So if we were referring to angle B, which side is opposite angle B, Josh? What? Opposite angle B is, say it one more time because I think I heard you say two different things. What's opposite angle B? Little b. So what would be adjacent to angle B? Little a. So opposite B, adjacent A. Okay, so now we're talking about definitions, how they're defined, and how you write these. So you're going to see a lot of this. Sine A, cosine A, tangent A, or B, or whatever. We're going to start off by using little a, little b, little c. What is... It's only about angles A and B. You never do the sine, cosine, or tangent of angle C. C is always going to be your right angle. That one's kind of out of the picture. It's either going to be A or B. Okay, sine of A. Sine is opposite over hypotenuse. So opposite would be A. Hypotenuse would be C. Cosine of A. Cosine is adjacent over hypotenuse. So cosine of A would be B over C. Tangent of A, opposite over adjacent. So that would be A over B. We're going to put numbers here in a minute, and then you'll see how we're going to do this today. You're writing up these ratios. That's what you're going to be doing today, to get down pat what the ratio is. Now we're referring to angle B. Okay, so angle B, sine of B, opposite over hypotenuse. So B over C. Cosine of B, adjacent over hypotenuse. A over C. And finally, tangent, opposite over adjacent, B over A. And when you get into actual trigonometry, you'll study the relationships between these things. Notice how the sine of A is exactly the same as cosine of B. And A and B are going to be complementary angles always. What's complementary mean? They add up to 90. Wouldn't they be complementary? Yep. Okay, so you're going to be given values in there and writing the ratios with those values. Evan?
So would it always be those? Like would it always be AC and BC and all that?
Yep. Yep. And now here's the thing though. What if they do this and they decide, hey, let's see if they really know, and give them a triangle MN and O? Okay? Or RS and T. But for all practical purposes, it is a standard to have A, B, and C. But I can tell you, you're going to be tested on your knowledge so that you just can't remember. You just can't memorize A over C, B. Okay? You can't memorize that because they're going to throw in different letters just to test you. Does that make sense? Okay. All right, so let's go down to an actual example like you're going to have. So first of all, you're going to have something like this example A. Triangle ABC. They give you BC is 7. They give you AB is 25. And they give you little b. And they want you to find the sine of A, the cosine of A, and the tangent of A. All right, so the first thing you're going to do is you're going to find the value of B. So this is good. We weren't able to do lesson 10.5 Pythagorean theorem, but we've done it so much for getting ready for the I-step. So you would have, first of all, 7 squared plus B squared equals 25 squared. And again, this is to find the value of B. So 49 plus B squared equals 625. Subtract 49 from each side. And B squared equals 576. And you square root both. And I do believe the square root of 576 is 24.
Yeah.
Okay, good. 24. All right. So now we're good to go. Now it's time to go ahead and write these ratios. So what you write is sine of A, and we're referring to A up here. And remember, we want so. All right, so opposite over hypotenuse, so sine of A, what's opposite? 7, and what's hypotenuse? 25. So you're just going to leave it 7 over 25 for now. Cosine of A, so cosine, remember, is ca. Adjacent over hypotenuse, so adjacent to A would be 24, and a hypotenuse 25, and you're going to leave it 24/25. And then finally tangent of A, and you're going to say, all right, TOA, opposite over adjacent. So looking at angle A, what's opposite? And what is adjacent? 24. 7 over 24. All right, for that, yep. Any questions? Now we're going to use a calculator, and basically what you're going to do, I want you to look at your calculators. You should have a sine, cosine, tangent button, and if your calculator is similar to what I have, you're going to put, for sine of 42 degrees, this is if you know the angle measure, you're going to get this approximation. You will use 4 decimal places when you're doing this, because you'll find out tomorrow you want to have a more exact answer, and if you estimate or round off with too few digits, you're really kind of shortchanging the whole thing. So you're going to put sine, hit the sine key, and just simply put in 42 and equal, and then I'm going to say we're doing 4 digits, so mine is 0.6691. The 3 after that means you would stay the same. Now if you have an older calculator, you might have to put in 42 and then hit the sine button, but it should be 0.6691. Anybody have any trouble with that? That's rounding off. Cosine of 84, so cosine 84, and I get 0.1045, and then there's a 2, but that rounds off. And then tangent of 76 would be 4.0108. You're going to go 4 decimal places on these. And that one, for 4 decimal places, the 7 would round up to 8. So if you know the angle measure, you just simply hit sine 42 degrees or cosine whatever. But there will be problems that we'll be working on tomorrow and in the future that you don't know the angle measure, but you know the trig ratio to it. So it would look like this, the inverse sine of 0.6691. So what you do is, notice that the second function would make the second sine inverse show up, and then you put in the 0.6691. We're doing just the opposite of what's there, and it comes out to 41.99, but you round to the nearest degree, and in that case, then it would go ahead and give you 42 degrees.